So I had a question about review number 8, the optimization problem. And also I hope you guys watched the Professor Dave video. In his video, it talks about two rectangles side by side, and that's more like what you're going to see on your exam. But I'm going to go through this problem with you because it'll go through the thought process involved to solve any kind of optimization problem. So I think it's a good idea to write down what you know and what you want to know. So we know that we're talking about a rectangle, and you guys know rectangles, length times width, and you know the perimeter of a rectangle is 2 widths plus 2 lengths. We know the area is 1,000 meters squared, and we want the perimeter as small as possible. So here's our equation. We know that area is 1,000, so we know 1,000 equals length times width. So what you want to do is you want to substitute so that we only have one variable. So we could solve for L here, or we could solve for W. It doesn't really matter. I'll just do 1,000 divided by L equals W. So now into the perimeter, that's what we want to find is perimeter, and then we're going to find the derivative of the perimeter to find our actual answer. But if you would go ahead and plug in 1,000 over L in for W. So I'll just write that right here. So we have 2 times W, which would be 2,000 over L. Does that make sense? So we take 2 times this. So 2,000 over L plus 2W, or 2L equals the perimeter. So let's go ahead and take the derivative of the perimeter. So remember, we could write this as 2,000 L to the negative 1 plus 2L equals the perimeter. So the derivative of the perimeter would be negative 2,000 L to the negative 2 plus 2. Now, when you set the derivative equal to 0, that's where you find your critical regions. So we're going to set this equal to 0, and we will solve. So what I'm going to do is I'm going to leave this 2 here, and I'm going to add this to the other side. So you know that'll become positive 2,000, right? And instead of writing 2,000 L to the negative 2, I'm going to write this as 2,000 over L squared. And now what we have is a proportion, so we can cross multiply. So we have 2,000 equals 2L squared. So 2,000 divided by 2 is 1,000 equals L squared. So L equals radical 1,000. So basically what this means is we would want the dimension to be, the length to be radical 1,000. And then if you solve this equation, you know that the width is also radical 1,000. So in this case, it ends up being a square, and we'll label this meters, would be the best rectangle to use the least amount of fencing. But on your exam, they're not going to both be equal. It's going to be more like the Professor Dave video. So I hope this helps reason it out. Write down what you know, substitute, so you have one variable, plug in what you want, take the derivative, and set it equal to 0 and solve.